Good morning, everybody. My name is Thomas Langer. I am architect of Project Helidon at Oracle, and I will show you a presentation about Project Helidon, its past, present, and faster future. So let's start with the agenda. I will start with a Helidon overview. I'll show you a bit what we have done in the past and where we are right now. Then we will look into the future and where we are going, what are the biggest changes for our project. And last, I will show you a bit of a demo in the source code, showing you the current implementations that are available and what we see again in the future and with the future of Java. So let's dive into it. We will start with introduction to Helidon itself. So Helidon is a framework for developing Java microservices, and one of the main things that we want to have with Helidon is that it's just a Java SE application. So when you compile your source code, you will get an application that can be run without any application server. You just run it on the Java SE directly. You can see also that the microservices intentionally in brackets here. You can actually develop even bigger services. It's really your choice. The technology does not restrict you. You can do even bigger monolithic type of services if that is your desire. So Helidon comes in two flavors currently. We call them Helidon SE, which is our reactive micro framework, which uses functional style of programming. What we call no magic. There are no annotations. Basically, it's what you see is what you get. The reactive APIs are needed currently to have a high-performant concurrent application because they allow you to do an application that doesn't block at all, meaning you can run a single application with a very big performance with a low number of threads in Java. Helidon MP is a MicroProfile-based implementation. MicroProfile is a set of specifications coming from Eclipse based on Jakarta Enterprise Edition. It is declarative with inversion of control, and again, this means that you can easily create your application by annotating classes, and then the kind of magic happens for you, and these classes become your endpoints. The main Jakarta E specs, this is based on our CDI, context and dependency injection, and JAX-RS, which are HTTP endpoints easily created through annotation. Again, if you have any experience with Java Enterprise Edition or Jakarta Enterprise Edition, this should be very easy to learn. In both cases, you can package your application to be run on the target environment. And we support a few packaging options. The first one, the default one, is what we call a hello executable jar. Hello jar means that the jar file only contains the code of your application. There is no shading of dependencies. You just have the classes that are compiled in your application. And all third-party dependencies and your dependencies are actually packaged in the original jars as downloaded from Maven. And by default, we put them in a libs directory in your application. And you can easily run your jar just by doing java -jar on the jar file. The second option that we support is JLink image. JLink has come into being with module system in Java, and JLink allows you to create just right image of your Java runtime environment that contains only the modules that your application uses, and of course all your dependencies. We support JLink image even for applications that use non-modularized dependencies. This is done through our custom Maven plugin. And the advantage here is that you don't need to deliver the whole Java runtime environment. So if you have a single Docker image, for example, then it's a very good way of delivering your application because it has smaller size than a Docker image that contains the full Java runtime environment. If you run on physical hardware and you, for example, want to run multiple applications on the same hardware, then the first option would be probably better because you share the Java runtime environment across all your applications and you don't need to deploy it again. The last packaging option is GraalVM native image. GraalVM is a Java runtime environment which supports quite a lot of features, for example, polyglot and so on. And one of these features is ahead of time compilation, which allows you to take your Java application and build native code out of it, native executable. So ahead of time means that during your build process, you run a specific task that will compile the jar file and all the dependencies into that one executable file that you can then deploy directly and run as a operating system executable. There are some restrictions for native image. You need to configure all your reflection. You cannot do a few things, but in general, it is supported by Helidon, and it's supported both in Helidon SE and in Helidon MP. In general, all of these approaches are easily containerized. You can create a Docker container out of them and deploy it to Kubernetes, for example, or run it locally for testing. This allows you to build applications really easily and through continuous integration and deployment and easily test them in your target environment. So now let's go back a bit on the overview. We will look into the history of Helidon. So we have started in the year 2018 with the first release, let's say first public release. Before that, it was just an internal project. We started on Java 8 and MicroProfile 3.2. And even our first version was still running on Java 8 because quite a lot of projects are running Java 8 up to this day, and we wanted to have feedback from as many people as possible. Then with version 2, we have switched fully to the modularized versions of Java, and we started with Java 11 and MicroProfile 3. And that was still based on JAVAX packages of the Jakarta EE specifications. With Helidon 3.x, which we released just last year, we upgraded to Java 17 and MicroProfile 5, and also this was the switch from JAVAX to Jakarta packages. So right now, we still support both of these versions, Helidon 2 and Helidon 3, because there are customers who, for legacy reasons, use the JAVAX packages of Jakarta, and we want to support them for some time. So you can use these two versions. And we are heavily working right now on Helidon 4, which the first alpha release was in 2022. We currently released Alpha 3, and by the time you see this presentation, we should have Alpha 4 released. And the main difference here is that it actually uses features of Java that are currently in preview. So we are releasing now on Java 19 with preview features. And when Java 20 will be GA, we will create an alpha version that runs on Java 20. So if you want to try Helidon 4, you will need Java 19 to work with it. So the active versions, Helidon 2.5.5, one of the biggest features that we introduced for security in Helidon 2.2 was the JEP 290 deserialization configuration, which allows you to restrict deserialization. And deserialization is one of the best known attack vectors on Java. So in Helidon 2, we warn you if you don't configure it, and this allows you to do quite restrictive configuration so you don't fall into this trap of security problems. As I said before, it's Java 11. One of those features we also introduced in Helidon 2 was our command line utility, which allows you to generate new projects from command line. You can find it in our documentation easily. The present version is Helidon 3.10, and from the list of features, I already mentioned some of them, but we have Project Starter, which is a new web interface for creating projects. So similar to what you can do in our command line utility, which we have also improved in this version, you can do also through the web UI. You can choose which features you want to have as a part of your application and generate a zip file that contains a project. When it comes to the deserialization configuration I mentioned with the previous version, it is now fully enforced. So Helidon actually starts with a 100% restriction on deserialization. You cannot deserialize anything in your application unless you explicitly configure it. And we give you tools to do that in Helidon itself. So for example, there is a JDBC driver that deserializes something and we know about it. So in Helidon, we package the configuration as part of the driver when you use it with Helidon. When it comes to support, Helidon is 100% open source. It is available on GitHub, and we do as much as possible through the open source channels. So new issues are submitted through GitHub. We have a Slack channel that is public that you can use to communicate with us if you need some help. And when it comes to official support from Oracle support, if you are a WebLogic customer or Verzzano customer, you can also get support through Oracle standard channels. Now, I want to dive a bit deeper into the specifications, so I will talk about the Eclipse MicroProfile. So I already mentioned it. It's a set of specifications for microservices that are missing from the Jakarta Enterprise Edition. It uses Jakarta Enterprise Edition as a base, a few selected specifications out of it, and it added new specs on top of it, which form the MicroProfile APIs. It's a vendor-neutral approach. There are multiple vendors participating on these specifications, and now we can have a look on what are the parts of it and what Helidon supports. And I will also talk about features that are Edition and Helidon specific. So the blue boxes you can see are MicroProfile specifications. I would say the core specification is a MicroProfile config, which provides support for collecting configuration sources and providing them through an API to your application. Then there are multiple things that will help your application be better, faster, resilient. So first one is MicroProfile fault tolerance, which allows you to add annotations that will do things like retries or restricting the number of calls through a single method so you don't overload your resource. Or maybe circuit breaker, where if your external service doesn't work, you will just stop trying to overload it and you will immediately return an exception that you cannot continue, rather than trying it over and over again and timing out every single time. MicroProfile metrics is one of the observability features. It's a spec that allows you to meter your execution. So you can do things like timers. You can just count the number of invocations. And also it exposes an endpoint that can be called by external systems, such as automated collection mechanism that you have in your Kubernetes environment. One example that is commonly used is Prometheus. And MicroProfile metrics expose the metrics in the Prometheus format. And the next spec is MicroProfile JWT authentication, which is quite a simple spec which allows you to collect bearer tokens from request and validating them against the JWT signature. it's a base, but it's very useful when you have applications which already obtain the token. So it's not like OpenID Connect, but it supports jobs. MicroProfile tracing, another observability feature. This is actually being slowly discontinued because it's based on open tracing, and open tracing is a specification that's outside of MicroProfile and has been discontinued and replaced with open telemetry. So we still support open tracing. In the next MicroProfile version, there will be an open telemetry specification that will move forward to the new specifications. MicroProfile REST client is a declarative client which allows you to create an interface that you annotate with JAX-RS annotations and use it as a client to another service. MicroProfile Open API is another specification that uses a third-party spec. This time it's Open API, and adds features on top of it to allow you to generate nice Open API documents from your endpoints. So you can add documentation through annotations to your JAX-RS endpoints, and a nice JAX Open API document will be generated. The last of the required specifications is MicroProfile Health Check. Again, this is an observability feature that provides health checks that are, I would say, specifically tailored for Kubernetes. So we have things like started health check and health checks that check liveliness and readiness, which are automatically executed by systems. So this is not targeted to be read by humans, like metrics. This is targeted to be read by a machine to restart your service when it stops being responsive, for example. The green specifications are part of MicroProfile, but they are not required. And in Helidon, we still support them. So there's MicroProfile GraphQL, which is an alternative way of serving your web endpoints rather than using the RESTful API. This uses the GraphQL API that allows you to do what I would call selects over HTTP, where you can limit the number, the elements that are returned, and it's just a different style of writing your applications. MicroProfile LRA. LRA is the long-running actions. It's basically distributed transactions for microservices. Then we have MicroProfile reactive stream operators and MicroProfile reactive messaging, which are actually, the reactive messaging is using the reactive stream operators. It allows you to listen to messages from a messaging stream and do operations on it, such as filtering them and then maybe calling another messaging service to send transformed messages. So this was the MicroProfile specific stuff. Then we have the Jakarta Enterprise Edition specs. They are mostly related to CDI and RESTful services, JAX-RS that I talked about, and to JSON processing and binding. We also support Jakarta WebSocket, so if you want to use a WebSocket endpoint, you can easily do that. On top of that, we have Helidon specific features, so we support fully CORS. Basically, all endpoints that are exposed by Helidon can have CORS specified, so you define which endpoints can access them. We have a full gRPC server and client implementation. So again, if you want to use gRPC as your protocol, you can easily do that with Helidon. We have also a security framework which adds quite a lot of features that can be easily plugged into your application. I already talked about OpenID Connect. That's actually one of the things that is supported by Helidon Security. So Helidon MicroProfile, just a reiteration, a blocking programming model. It uses inversion of control. It's based on CDI. You can create easily CDI beans. It uses JAX-RS HTTP endpoints. And it's a natural fit for Java and Jakarta EE developers that have experience with it. And now let's have a look on the other side of the fence, on the, let's say, low-level programming with Helidon Reactive. We provide the same features that we have in MicroProfile. In our reactive environment as well. So basically anything you can do in one environment, you can do in the other as well. There will be different APIs because the reactive has some requirements that just cannot be fitted into the APIs that are created for CDI. We do have some libraries that will allow you to write truly reactive, non-blocking application with backpressure, such as our web client, also the reactive messaging, which is actually taking some of the APIs from MicroProfile as well. And of course, you can write a gRPC application, you can write WebSocket application, you can use fault tolerance, health checks, metrics, and so on, with the flavor of the reactive code. So Helidon SE is our reactive programming model. It is based on reactive streams, but we are actually using the Java Flow API. We have decided to switch to it as soon as we could because Java Flow API is part of the JDK. You can use it in any application, and we didn't see a reason to bring in a third-party library. This is actually one of the things that we try to do in Helidon as much as possible. If a feature exists in Java, we will use it from Java rather than using an alternative third-party implementation. So our reactive streams are Java Flow API. Our logging is based on Java util logging and in the latest versions on system logger, reducing dependencies as much as possible. Our reactive programming model uses the Flow API for the truly reactive stuff. We also use completion stage for the cases where you have a single future result. Completion stage allows you to do chaining of future results. It also fully supports backpressure. So if you have a tool that requires backpressure, meaning you want to process one by one your incoming messages, then you can do it easily. You can process your message, request another one. When it arrives, you will process it and request another one. Helidon SE is designed for highly concurrent services. If you want to do something that's really highly concurrent and provides good speed, you have no choice. You need to go with reactive. Nowadays, there are a lot of reactive frameworks out there. We also support it because we want you to be able to build something that's really fast with a lot of concurrent requests. Obviously, there is a trade-off, and in this case, the trade-off is that it has quite steep learning curve. Reactive programming is hard. We know about it. We still have to use it because there is just no other way how to write it in Java. Of course, the maintenance is harder as well because you need to write quite a lot of code that is not your direct business code, but it's code that's required for the reactiveness to work correctly. So now I will just show a bit of architecture, a very high-level architecture of Helidon that is from version 0 to version 3. We base our web server on Netty. Helidon SE is used as the groundwork for everything, and Helidon MP is built on top of it and adds the higher level features for annotations and so on. We do no packaging tricks. As I said before, we are based on hollow jars. There is no shading. We are not trying to put a lot of jars together into a single jar. It's just as Java was designed. We are doing no class loading tricks. So in the main code of Helidon, we don't use a single place where we would create a custom class loader ourselves. There may be some class loading things happening as part of the CDI implementation, because of course there you generate proxies and so on. And we have one library, specifically one, that actually uses a class loading trick, and that's to separate the messaging because we need a different version of JMS loaded. And that's one single library that we know. It's transparent and simple. So we try to keep it as much as possible Java SE application without tricks. So now, where would you start? We have web pages, helidon.io, where you can find everything about Helidon. So here you can see that we have chosen the starter page where you can select the flavor and then all your features and download an application. You can also click on the documentation to get access to Helidon documentation for each of the versions. So now we have covered the area of what we have available right now. And now I want to go into what we are doing for the future, what we are working on, and where we see that Java service space will move to. So I have already talked about trade-offs. We have Helidon SE, reactive, which has great performance, high concurrency. And we have Helidon MP, which is easy to write, easy to maintain, easy to troubleshoot, easy to learn. But the trade-offs are quite heavy. So if you write reactive code, it's really hard to do. You make a simple mistake and your code just falls apart. On the other hand, in MP, you are limited by the number of threads. You cannot go further than what Java will allow you. So if you reach 400 threads, or maybe it's a bit higher, the JVM will just limit you. You cannot do more because of limitations like the thread stack size and number of CPUs on the hardware, because then you have context switching, which will slow down your application. So in the end, your performance is average. It's great for applications where you deal in tens of requests per second. That's absolutely fine. That will handle it. With reactive, you can get to thousands, tens of thousands requests per second. It depends really on hardware. The current numbers, talk about like 200, 300,000 requests per second. And again, it's very much dependent on the environment. But we can see that in both cases, there is something missing. Like, we want to do it easy and at the same time performant. Well, I think we have an answer for that. And it's called Helidon NEMA. It's the first service framework that is based on virtual threads. So what are virtual threads? It's a JEP. There are actually two JEPs. This one is for Java 19. There is a different number for Java 20. And virtual threads are lightweight threads managed by the JVM that help us in writing concurrent applications without the restrictions of platform threads. The Java team came up with Project Loom, which is bringing in improvements that will allow us to write such applications. In Java 19, this is a preview feature. In 20, it's also a preview feature. As soon as it is released as a non-preview feature in Java, Helidon will release Helidon NEMA as a production-ready code. So now you can choose between platform and virtual threads. And platform threads are the threads that we know from Java forever. They just run and you can do what you could do with them. There is no difference. Virtual threads, on the other hand, are actually not the same. They have the same API, but you can create thousands, millions of them. And virtual thread will be bound to a platform thread from a custom foreground pool only when it executes code that needs to run. And as soon as it reaches code that is blocking, so for example, you go to a socket and you ask for input stream.read, the virtual thread will be unmounted from the thread and will wait until that method can continue. And this is all handled by the JDK, by Java. We don't need to take care of that. So from our point of view, we just use the normal Java code, but underneath, it will make sure that we are not using the platform threads unless we are actually working on something. So very great fit for highly concurrent applications that do blocking operations, which is exactly what most of microservices do. In the end, your microservice will most likely call another service, go to a database, or a combination of that. So in all of these cases, virtual threads are very helpful. So what do we do with Helidon NEMA? We have built it on virtual threads from the grounds up. It has the scalability of reactive code with the simplicity of imperative code where you just write what you want to do. We have collaborated with the Java team because obviously it's a new thing. We wanted to do this right. First and foremost, we wanted to make this fast so we can compare to the best servers that are based either on reactive or event loop approaches, such as Netty that we use right now. It will be used as heart of Helidon MP, and we will also introduce a new low-level API for NEMA itself. Since Alpha 3, Helidon MP is already based on Helidon NEMA, so it already benefits from the non-blocking features that are hidden underneath the virtual threads. And you can try it right now. It's available in Maven Central. When it comes to the performance, I will show a quick chart later, but that was one of the basic requirements, that we need to be comparable to the performance of Netty, and otherwise it doesn't really make sense to work on this. And as you can see, we already have Alpha 4. We definitely continued working on it because the performance is comparable to Netty. And we are really happy about that because that means that we can deliver something that's easy to write and at the same time has great performance. So how does it look? We have Helidon NEMA server, which supports right now HTTP 1.1 fully. HTTP 2, it works. It's still in progress. We are working on it. gRPC, and gRPC is based on HTTP 2, so we are also still working on that a bit, and WebSocket protocols. The server is written to be extensible for our other protocols, so if you decide to write a custom TCP protocol, you can easily do that with Helidon NEMA. The extension points actually use the bytes that are available on the network to identify the protocol, so you can run multiple protocols on the same port, which is also by design. We wanted to be able to run a gRPC application, WebSocket application, and a HTTP2 application on the same socket, so you don't need to open multiple and have complications when setting up your environment. One of the things we also designed from the beginning is testing support, so you can easily test your endpoints both over the network and without network. And I will show a bit of that in the source code. So what is the thread model? That is really the interesting part when it comes to virtual threads. So socket listeners are platform threads. There is one per port that is open. You can open multiple ports. These are platform threads for the simple reason that virtual threads cannot be daemon, and we need the server to be up and running. So we decided to just use platform threads because these just don't matter that much if you use virtual threads for everything else. HTTP 1.1 by default uses a single virtual thread per connection. Connection can be longer-lived thing in HTTP 1, and each request then runs on the same virtual thread. HTTP 2, on the other hand, uses a combination. There is one virtual thread per connection, and then there is one virtual thread per each stream. And a stream in HTTP 2 is basically a request-response exchange. So in HTTP 2, we can see the true power of virtual threads, where we create a huge number of them in a very short time, and it still works. All routing that you do in NEMA-based Helidon is executed on a virtual thread, which means that it can block as needed. So it doesn't matter if you do the low-level APIs or you use Helidon MicroProfile. In both cases, you can call an HTTP endpoint without any danger of killing your environment because you'd have too many things in memory. So we have moved the problem of performance one level away from what it was. Before, you needed to take care of your thread pools and how many threads do I create and will that be sufficient for my performance, and it will be still okay for the memory and for context switching. Now, this problem has gone away. There are still problems. There is always another step in performance that we need to solve. For example, you still have connections to database and you still have connection pools. So now if you have 10,000 parallel requests on your server, and if each of them wants to go to a database, obviously you will need to throttle them. There will be a connection pool that will only be able to serve 15 at the same time. Maybe I'm making the numbers up. The good thing here is that the other threads will just wait. And as long as your connection pool is implemented using Java util concurrent locks, you are fine. It will not do anything. The virtual threads will just wait in line. But obviously, if they wait for too long, you may time out, you will get an exception. This hasn't changed. This is still the same. It worked that way for reactive. It works that way for virtual threads. But at least the thread problem has gone away. I have a bit of code here just to show, you want to do an operation that is blocking. In my case, I use thread.sleep. Of course, this could be, I want to call a third-party service over HTTP. If you do that in reactive, you will eventually end up with some reactive things. So for example, here, this is using our single, which is a flow publisher for a single result. And we created right now through async, which is our, it's a tool that allows you to execute blocking code asynchronously on a custom thread. If you imagine here that you are calling that HTTP request, if you didn't have a reactive web client, it would be very similar code. In the end, even if you use the reactive web client, you will have this future that returns your response, and you will have the future that may return an exception if something wrong happens. Now, if you do the same thing in blocking environment, in our case on virtual thread, you do your call within the thread and then you just do, return the result. If an exception happens, it will be called by the framework and you will get an internal server error. If it's an exception that is understood, so we have some HTTP exceptions, it will automatically send that response code. So your code is readable and much easier to write. So now I have the numbers. This is an example of JSON processing on HTTP1, which is the first two numbers, and then HTTP2 plain text request over TLS. And this is actually an example of in Helidon comparing original code and the new code on Nima. And you can see that the increase in performance is quite significant. And there are two reasons for that. First reason is the code is very easy to write, and there is less steps to get from an HTTP request to your endpoint. The second reason is that in virtual threads, it's really straightforward. We just go from, I have an input stream and output stream, then I invoke my endpoint, and then I close those streams, and I'm done. In reactive, we need to go from the Netis event loop to our reactive streams, and then have quite a lot of what could happen in the future, and I need to handle it somehow to correctly end my connection and return a response or an error response. And we actually pay a price for that. All these layers that help you to make the code work correctly will also add some performance overhead. And sometimes this performance overhead also is a notification that we need to improve some parts. But in general, the virtual threads for us are just working way better because of the simplicity. If you are interested in this feature, you can go to our Nima web page. We have the announcement blog article that describes what has been done and the link to an example and how to download our versions and use them in your application. So I would recommend that. I think honestly that this is the future of Java. And as soon as virtual threads became a preview feature in Java 19, I thought that this is the right thing to do, and we went immediately and started working on that in Helidon. And I hope that was the right bet. So now I will just show. Okay, let's just go here. So summary of Helidon: it's a lightweight, innovative framework for services that can coexist and complement your existing investments. It's really created to be compatible with cloud environments and Kubernetes, but of course it's just a Java SE application, so you can run it even on physical hardware. We will not think anything less of you. It's just great environment, and we hope really that you are going to try it at least out. Here is a list of contact points. So we have a Twitter account, the web pages I talked about. Our blog articles are on Medium. The main page you will probably want to look at if you are interested in what we do is the GitHub page, because that contains everything about our source code, the issues that we have on Helidon right now, and we also use it to plan our work as a team. So if you look on the projects, you will actually see our project board. So if you are interested and if you want to help with Helidon, that's the place to go. We also have a YouTube channel and then the public Slack channel that you can use. Okay, so this has covered the presentation part, and now I would like to show a bit of the source code, because in the end, Java is, about coding. So let's have a look. What I have prepared here is an example of what we have right now and what we will have in Helidon 4 with virtual threads. So the first is the simplest application. This is Helidon MicroProfile. I have a jakartified resource that is bound to the root path, and then there is an endpoint where if you invoke /1, it will just return a 1. This code stays the same. There is no difference between Helidon 3 and Helidon 4. There is no requirement to refactor. You just can upgrade your application seamlessly, unless you do some lower level programming and updating our reactive routes. So for the normal applications written for Helidon MP, they just stay the same, and they will automatically benefit from virtual threads. We can see that the MP application in general is very simple, because you just need your resource. You need beans.xml to tell CDI that you have a bean in this project. And then application YAML is Helidon specific configuration file that is always picked up, where you can define your server port and server host and whatever configuration is needed. One optional component here is the logging.properties. This is a setup of Java util logging that you can use with Helidon. You can also use your own logging framework. We have a blog article that shows you how to do that with Helidon if you want to. Okay, so that was MicroProfile. I will just show the POM file as well. We have a bundle that is called MicroProfile Core, which contains the main, I'll just make it a bit bigger so you can clearly see it, which contains the main specification. So there's CDI, jakartified, and JSON. And that's it. Now, if you just do Maven package, it will create a jar file. You can do java -jar on the jar file and it will run. So now I will go to our reactive code, and reactive is, as I said before, actually what you see is what you get. You code the stuff and it will work exactly as you code it. So in this case, we create a web server instance. You can see that we are creating routing. Then we configure the server using configuration. And again, there you will find application.yaml here. Then we start the server. This actually returns a future, and because this is the main method, we can just block with a timeout until the server is started. And the main part here is the routing. So here you can see that there are two routes. One of them is /remote, which is just a service that sleeps for 5 seconds here. And then we register a service called reactive service that is registered on the root. And now the reactive service is our business logic. So I also use this to demonstrate what you cannot do in reactive. So we can see here that we have the routing of the service, where we say that /1 is handled by this method 1. So if we go here, you can see that it gets a request and a response. And the code here uses a reactive web client to call the default endpoint. It returns a future of a string. And then I say that when this string is returned, please send a response. If there is an exception, call response.send with a throwable, and that will send back either the internal server error, or if you map exceptions, it will send the correct response code. Now, what I really wanted to show here is this part, and that's why reactive is so complicated. If you decide that you do a blocking operation, and in this case, it's very simple, right? I'm calling await, which will just block and wait until I get the response. But you can also do it without realizing it. It can be a file system operation. It can be, a third-party library that blocks somewhere hidden that you don't see. If you do this, your server is basically broken because you are blocking on a thread that is not allowed to be blocked on, and you may actually lose performance because of this. This is very dangerous, and that's the reason why reactive is hard. Now, with the blocking service, we have tailored the APIs to be very similar with our reactive. So if you know our reactive, it will be very simple for you to write our NEMA web server. So there is also routing. And in the routing, again, I have two endpoints. I have the remote, and then I have the blocking service bound to root. And you will find out that it does exactly the same thing as our reactive service, but this time it's blocking. So when I do the one operation, I just get the string response and I send it. I can block as much as I want. So this is the main difference. And the last thing I want to show is how complicated it gets when you want to do something more complex in reactive. So let's say that you want to do things in sequence. If you use blocking code, you just do a for cycle. You just do stuff in sequence. You collect the responses, you send them back. That's it. When you read it as a user, it's very simple. You get a count from the request, then you prepare a list of responses, and then for each repetition, you just call the remote client and add it to the responses, and that's it. And now, if you try to do the same thing in reactive, and now let me just find my method. It's sequence. You need to understand that how to create a sequence. That's the first problem. So, well, I know that I can use multi.range, which is a Helidon API. Then you also need to know that you need to use the flatmat operator that will do stuff in the future and in parallel. So you will create a new multi that will be created from the responses from this. And then you can collect it into list and do similar things that we did in there. It looks simple, but you need to know quite a lot of stuff to be able to write these two lines. And if you want to do it in parallel, then it's even more complicated, because then you need to know this section. And even in my experience, we actually had to work on it, 2 people for 20 minutes to find out exactly how to do it correctly, so it's really parallelized. And again, if you do that in blocking world, you have an executor service, you just submit your stuff to that executor, you wait for it to finish, and you are done. you just do future.get. This is what you can do with virtual threads. So that was a dive into our future, and I've also tried to show you what you can do with reactive and with MicroProfile. With that, thank you for your attention. I hope you enjoyed my presentation and enjoy the rest of these Java days. Goodbye.